Hello, friends, colleagues, students, C++ learners, YouTube watchers. This is Dr. Satish Singhal, PhD, Professor of Computer Information Technology at Rhodes State College in Oklahoma City. And today I'm going to talk about something called C++ classes Rule of 5. Okay? There used to be Rule of 3 that seems to have been replaced by Rule of 5 in C++ 11. So let's just dive in and see what that is. So there used to be C++ classes rule of 3. This is replaced by C++ 11 rule of 5. Rule of 5 requires that for classes that have a pointer data member and memory for that data member is allocated inside default and explicit constructors, then to promote deep copying and efficiency of moving resources, one must implement the 5 items for that class. That's a mouthful, but we'll see what those are. And those five items are shown in next slide. So to implement these 5 or rule of 5, you need a copy constructor, you need an overloaded assignment operator, you need a destructor that can be virtual. This used to be rule of 3 before C++ 11. C++ 11 has added 2 more, became rule of 5, that a move copy constructor and a move assignment operator. Move copy constructor and move assignment operators are used through a function called move, std : move, when we no longer need the object being copied. That's efficiency consideration. So last two were added by C++ 11 as an efficiency measure when source object needed copying and assigning, but source is not needed afterwards. So that's this case there. Okay, so to implement rule of 5, we're going to show you a simple integer class in Xcode. So we're going to go to Xcode and we won't come back to the PowerPoint. So in fact, I'm just going to close it, save. Okay, so this is my Xcode. Sorry. I'm going to maximize it. Hopefully fonts are big enough for everybody to see. So I'm going to include IOStream and string because I'm defining a class called integer, and this, you can think of this as a wrapper for an int type where int is really stored through a pointer. Okay, so class has only one private data member called data, but that's a pointer to an integer. Initialization with null ptr is done just as a sake of precaution. And we have a default constructor. So here I'm just adding the value 0 to the pointee of data, and it can easily be done through this initialization list, and I can just assign the memory for this pointer right here, and this is perfectly okay. You can always do that in initialization list. There's absolutely no problem with this. And from each item that we're going to show you, except this string, toString, we're going to have a output statement to see when it's being executed. Okay, so we have not gotten to rule 3 or 5 yet. We are only showing constructors right now. And then class is explicit constructor, which takes a value val int, and we do that through initialization list also, that the data that is pointer, it gets a value new int val. So memory allocation is being done here, and we pass the val to it. So which means pointee of data, data is a pointer, its pointee, which sits somewhere else and data stores its memory, will store val, and we have output statement from that. Okay, now we get to rule of 3. So these were simple default and explicit constructor. So rule of 3 requires that we have to avoid shallow copy and to promote deep copy, we have a copy constructor. CTOR means constructor. And its signatures are like this. We say const, integer, and other. And we just do the copy, and copy mechanism here is pretty simple, and still I can do it through initialization list. That point of data gets new int, but the value provided is the what point of data in other is, so dereference value of other.data. You can put it here in the initialization list, or you can see here data equals new int dereference value of other.data. So that works either way, it works fine actually. So this was the first part of the rule of three, old rule of three, or first part of new rule of five. Then it needs an assignment operator, and signatures are all, argument list is identical to the copy constructor, so don't forget that. But it does return a integer type. We always put const so that objects are not modifiable when they're being returned. Okay, so here we say that if address stored in this pointer is not same as this one, which means we're not doing any self-copying, then of course this is always required in every assignment operator. When you do assignment, excuse me, both objects are pre-built. So if you're gonna, this object is pre-built, if you're gonna delete, put new value in there, you gotta delete the old memory allocation. And then notice the same code here, and we just copy the value stored in the pointy of other.data output statement, and then we return dereference value of this object. So that's the second component of rule of three. And goal of destructor, which is the last part of rule of three, and if we like we can make it virtual. There are advantages of doing that, although it's memory overhead. Well, you just delete the data pointed to by the data. Okay, so it will delete the memory allocation, although pointer will not be deleted. Okay, so that's the third part of the rule of three. Now we add something called move constructor and move assignment operator. That is part of the rule of five. So when we do that, we pass it by a double reference, because you could move things efficiently by passing a double reference. This is called, by the way, there's a technical name for that, and is called R value reference. The terminology is cryptic. I'm not going to go into detail of what that means, but I will show you application of this copy constructor. Actually, it's copy constructor, move copy constructor. And this is implemented when there's a move function in C++11 when that is used. And that's where you need this 2 ampersand. There are other applications of it, but I'm not going to go into that right now. But just take it that move copy constructor should have this 2 ampersand rather than 1, because we are passing a R value reference, which means you're really passing a by reference something that is an R value. R value is something that can only be on the left hand side of a assignment expression. So what is the definition of R value? R value is something that can only be is allowed to be only on the right hand side of an expression. L value could be on either on left or right, doesn't really make any difference. So all the primitives are R value references. All primitives. Okay, I'm sorry, all literals, not primitives, literals. R value reference. So if I say value 5, that's a R value. You can't say 5 equal to 10 or something. It can't be on the left hand side. Okay, so syntax for move copy constructor is class name, and then we are passing the same class data. Here we don't put const, and 2 ampersand means that what is being passed other is not a L value reference, it's an R value reference. Okay, so really code here is not, actually code here is quite different. I'm sorry, I meant to say it's not same, but it is quite different. Okay, so let me just collapse some of this code here. Okay, and you can see here a memory allocation was done, but when you do the move copy constructor, no memory allocation is needed because data will just steal the resources of the other dot data. In other sense, you can say data will just directly point to other dot data. I'm sorry, data will point to exactly where other data is pointing to. So data will just point to where other dot data is pointing. And that's the way to steal the resources without having to do the memory allocation that we have done here. Okay. And since pointy of other dot data has been stolen, I just set it to null PTR. And there's a special syntax to invoke move copy constructor. We'll show you that shortly. And then move assignment operator is the fifth part of the rule of 5. And here we return by a const reference, but the argument list is same as move copy constructor. Okay, and the code is combination of, you still have to delete the data, you still have to make sure that self-copying is not being done, but then again you are stealing the resources of pointy of other dot data, so you just do that. You don't really have to allocate the memory the way it was done in the assignment operator here. See? Okay. So that's the big difference, that you're not doing extra copies, you're just transferring the resources. That's the resource transfer. Data just directly pointing to where other dot data was pointing to, and this will be stolen basically. Its data will be just stolen. There's no deep copy, but there's no shallow copy either, by the way, because this R value reference, copy by R value reference, make sure that there's no shallow copying either actually. Okay. And then rest is same. We return the reference value of this and an output statement. I put a toString function so that I can print the value stored in the pointy of data, and then in this case, at least because data is pointing to a integer, I can use toString. Floating point, not a good idea, but for integer it's okay, and it's just going to print the value of data. Okay. We have two functions, standalone functions, non-member of class. This one is print integer, that takes integer by value, not by reference, because you don't have to, if you pass by reference, you don't really need any constructors, copy constructors basically. Okay, but we need it when we pass it by value, and here's being printed actually. So I'm going to show you first use of move copy constructor. Actually, let me show you both. Use of move copy constructor and use of regular constructor, a copy constructor. So let me just do this. Here I'm creating an integer value 5, which has a value 5. So I'm passing 5. So default, explicit constructor will be called, which is this one, and data wherever it points to over there, a value 5 will be stored. Okay. All right. So I create an object of integer type called value 5, which actually will have a integer 5 in there. So let's first do the regular, see how the regular copy constructor is called. So I'll say print integer, and I just pass it value 5. Okay. Okay, let's run only this much program. Actually, let's even comment out this one. Okay. So let's just run only program up to this point. Okay, so our output is this right here. Let me actually kind of copy that, and Visual Studio, I could have just brought this panel there. Here it doesn't allow us to do that. And I'm just gonna temporarily just post it here, and then I'll delete it. Okay, so first item we got from explicit CTOR, because this was being called. And so explicit constructor is called here, and that is the statement from there. Then I get printing integer value 5, that came from here. And then I call the print integer function with value 5. Notice value 5 has to be copied inside the value, but that cannot happen unless you invoke the copy constructor, copy CTOR. And we have shown this in person to you also. When copy CTOR is called, then this code is executed and I get this output. Okay, so that's simple enough. And then finally I print 5. That is the statement over here in the print integer function. And then our destructor has print statement also. Then I have two destructor calls, two of those. So notice one constructor call, second constructor call, so number of constructor call and destructor call match. So everything is good. Okay. So that's the regular rule of 3 behavior. We have shown that to you. To you means student at Rose State College many times, not the people in the YouTube land. Now I want to do the next thing and add this statement where I'm actually invoking purposely the move copy constructor. Okay, so this time I'm saying, okay, still use the print integer, but don't use the copy constructor because that makes a deep copy. And basically I'm saying here in this line here that I don't really want value 5 after this program statement. So just do whatever you want to do with it. Just move it to print it. Okay, so that's the key. So move is a function in std that can be called anytime you want an object and its resources to be transferred to somebody else. Just move it. Think of this like a moving van. It just takes the object that you're passing to it, it's just moved to do whatever it's supposed to do. Okay, think of this as like a moving van. All right, let's see what happens now. We'll get one more print, but something different. Okay, so I'm going to copy that over here. So notice I'm not going to worry about the destructor call, and this time it will almost seem like, actually it's not, destructor and constructor is still matching. So once I add this line here 88, that print through move, call the print integer but use the move function, Then you can see this move CTOR is being called. So really when I do 88, this one, my move constructor is being called. In the process of calling the print integer function, let me collapse that. Okay, collapsation is not working. Okay, fine. And then the 5 value is being printed here again. Okay. Sorry, this one. That was earlier. And then of course you can see that number of constructor and destructor calls are still matching. 1, 2, 3 constructors, 1, 2, 3 destructors. Okay, so that's the application of move constructor. If you don't really trust me, I could show you through the debugging process, although my video will get longer. So I'm gonna put a breakpoint here, over here, and then run it. So it's gonna stop here, and then this is the step over, step over, step over. Now I do the step into. Okay, and then sometime in Xcode things work out backwards actually. So it's entering the move constructor now, move copy CTOR now actually. Okay, there you go. It stole the data from other.data. Here's my output statement. It's going to show up right here in a second. There you go. And it's back here. Okay. So that's the execution of the move copy constructor. All right. Now the second thing I want to show you is the use of regular. Actually, I already showed you regular copy constructor. The regular assignment operator and the move assignment operator. So what I'm going to do, I'm going to uncomment, maybe I'm going to uncomment all of it actually. So that's command plus this, okay. So we have another function here which returns an integer by return mechanism. It asks user that enter value of int, takes an input for that, calls the explicit constructor for the integer class and returns that object. Okay. So here I think we have a number of options. Here the regular copy constructor will be called, but we have already seen that. Let me try to see. Okay, this I didn't think of that before. So maybe I can try the move here, and if that doesn't work, I'll have to eat the crow and go back. But looks like it is working. So let's run this one, and I'm gonna remove the breakpoint. I may introduce that later. So stop the previous execution, start it again, and it's gonna ask me some new value. I'm just gonna say 33, and that's when I got it. So let's copy and paste the whole thing to the results panel here, and let's see. I may, really honestly speaking, if I had 2 columns I could do that very nicely, but let's do one thing. Let's start text wrangler, paste the results into that, and then match line by line. Actually, I think that'll be a pretty good idea actually. So bear with me. Text wrangler, it's not test, text wrangler, control V, and now I can do this magic. Okay, my magic is failing. make it smaller. Okay. Now I can move it and try to match it the best I can. So we had already seen up to here, excuse me, that was up to line 88. So let's see what we do is, here let's increase the space just a little bit and get our text wrangler back. So now we are calling this function called get integer. That's where this dialog is coming from. Enter value, and I enter 33. Okay. So value 33 is stored into value users. Then there will be explicit constructor called, because if you go back to get integer function, explicit constructor is being called right there. Okay. That's this line here. And then instead of saying return x, I'm saying std : move x. And this is very efficient because I really don't need the object x afterwards. I really need its value only. So honestly speaking, there is no, okay, this might shock you a little bit, but this is inefficient because, hey, x will be destroyed anyway. All we want is value. So there's no point to use the copy constructor to make a copy of this when we have available a move constructor, which is a move function really, std move x, where its resources will be just transferred to this one. Okay, that's the whole idea. So really, this is very efficient. It's a good idea to always use that. Okay, and in this case, because a dynamic allocation is being done, this is very useful. All right. Okay, let's take a look at that. So that's why you have this move ctor call right here, because at this point, move constructor makes a copy of that and it stores that into this value user. Okay, and if I run debug line by line, it can clearly show you that when we execute this line, it goes to the move constructor, move copy constructor. Okay. All right, then we are printing the integer value user, this statement here, and that will be 33, and of course we can see that it is printing 33. So right now we are aligning around here, around this line. Okay. Then of course I create another variable called value 10, give it a value of 10, an explicit constructor is being called there. Then I create a, eventually I'm going to copy this into this, so I create another variable of integer type called copy value 10, and in this case default constructor is being called. So these two corresponds to these two here. All right. Okay. Then I do my regular copy. Okay. So over here, when I do that, I get a call from regular assignment operator. Okay. And once again, we can run through debugging and show that when this statement is executed, our regular assignment operator, which used to be old rule of 3, is being called. This guy over here. Okay. Go back. All right. So regular assignment operator. Then we print that. and the 10 is being printed by this line here. So this line and this line are the same. Now I want to show last thing, the use of move assignment operator. So I create another variable called value 9 and put a value 9 there, and so explicit constructor will be called here. I think I can move it just on the same line. So over here, just a second. Yeah, over in this line, this explicit constructor call is being made. And then I create a copy value 9 where I will be copying, doing the assignment into, and the default constructor is called there. And then I make a assignment operator where I will force the move assignment operator to execute right here. So when this assignment is being made, you have told C++ that don't call the regular assignment operator, call the move assignment operator. Okay, and that's why we get this call that, okay, let me go down just a little bit, that from move assignment operator. So this call is really coming from this line here. Okay, so we have shown you all 5 destructors. Of course, is called anytime your object needs to be destroyed, but we have shown you the all other 4, which are regular copy constructor, regular assignment operator, move copy constructor, and move assignment operator. Okay, for my students, this program will be available on their course management system. Others who want this, just put a message and I can put that into my blog, and you can get a source code from the blog. So once again, this is Dr. Singhal from Rose State College in Midwest City saying goodbye, and we have illustrated for you in this video the C++ 11 rule of 5. Thank you. Bye.